All right, today looking at 3.7, solving systems of equations using Cramer's rule. We're actually going to start getting into the meat and potatoes of how to make the process of solving systems much more efficiently with matrices. All right. In order to use matrices, what we're going to have to figure out first is how to determine determinants of matrices. You can kind of think of determinants as almost like a matrix barcode or just a number associated with any square matrix. And that's kind of the big thing. Every square matrix has a determinant. So it must be 2 by 2, 3 by 3, 4 by 4, 5 by 5, 6 by 6, 7 by 7, and so on and so forth. Okay, determinants. If you want to write this down for your notes, you are welcome to, but to be honest, it's pretty straightforward after you get a couple of these down. Okay, so determinants, what we do is we're going to multiply the diagonals, and then we're going to take the difference of the two. All right, and this is with a 2 by 2 matrix. So notice the brackets have now turned to straight bars. So when we're talking about a matrix and we have bars instead of brackets, that essentially means we want to find the determinant of this matrix. So again, I'm going to take the product of the diagonals, or each diagonal, which is 14 and 12, and then you're going to subtract the 2. So the determinant of this matrix is 2. All right. If we look at the second one, we find the product of each diagonal. So we have 0 and 35, and then we're going to subtract the 2. The determinant of this matrix is negative 35. All right. 2 by 2s, again, very straightforward when finding determinants. 3 by 3s take a little bit. And we're actually going to use kind of this trick. We're going to use columns to evaluate the determinant by hand. In pre-calc, you guys are going to use minors and cofactors. All right. This method, doing the column method, is nice. It's easy. The only problem is it works for 3 by 3s. It doesn't work for 4 by 4s. And good news for you guys, we're not going to do anything higher than a determinant of a 3 by 3. So what we want to do when we're finding determinants of 3 by 3s, again, it's a little process. It's a little trick. You're going to copy the first column over. You're also going to copy the second column over. Okay. And then just like before, we want to use our diagonals. So 2, 1, and 3 is 6. I'm going to add to that the next diagonal, 1, 4, and negative 5, which is negative 20. And then 2, 3, and 6, so negative 36. Okay. So we're going to take those 3 diagonals, multiply down the diagonals, and add them together. We're going to subtract from our diagonals going the other way. 5, 1, and negative 2 is 10. 6, 4, and 2. 24 times 2 is 48. And then 3, 3, and 1 is 9. So we multiply down our diagonals to find that sum. Multiply up the diagonals, go from there. If you notice, we have 58. So this one is going to be 67. And then up here, we have negative 56 plus 6. That's going to be negative 50. So negative 50 minus 67 is negative 117. All right. We'll do the same thing on the next one, just to make sure we kind of have a solid foundation for things. So again, to start finding a determinant of a 3 by 3 matrix, we copy the first 2 columns over in order. Then we multiply down the diagonals from left to right. So we have 0, 3, 5, which is 0. We have 4, 4, 2, which is going to be 32. And then we have 2, 1, and 6, which is 12. We're going to subtract that from my diagonals going the other way, which are 2, 3, and 2. So we have negative 12. We have negative 6 6, -4, and 0, which is going to be 0. And then we have 5, 1, and 4, which is 20. All right. So if we look at the bottom here, we have 8. Up here, we have 44. 44 minus 8 is 36. All right. So that's the process of finding 2 by 2 and 3 by 3 determinants. For the latter part of the day, we're going to look at 2 applications of determinants and how they are useful. The first being areas of a triangle. Okay. So when we look at areas of a triangle, let's say you're given 3 coordinates on a plane. I'm pretty sure most of you did this in your honors geometry class last year. But when given 3 points, you probably had to do a lot of calculations, you know, figure out what the base is, figure out what the height was of the triangle, construct that perpendicular altitude from one of the bases to use your 1/2 a, or 1/2 times base times height formula, okay? Areas of a triangle are actually going to be done a little bit easier and more efficiently with matrices. So what we do is we put the x coordinates in the first column, we put the y coordinates in the second column, and the third column is going to be all ones. Then what we do is we find the determinant of that matrix. Turns out that's going to be the product of the base and the height in that given triangle. Then we just have to multiply it by 1/2. All right. So as we go through things, we want to set up our matrix. We're going to look for the area of this problem. So we're going to take 1/2 and we're going to multiply by the determinant. X is going the first, Y is in the second. The order of these do not matter. Okay. So let's say you put 412 in the first row and put 0, 0 in the bottom. You would still wind up with the exact same answer in the end. Okay. So what we have here is we have determinants, and we're going to use our determinant to find something else, right? So in these situations on your homework today, you guys, you can actually use your calculators. With 3 by 3s, generally a time saver. If it's just a 2 by 2, to be honest, it's going to take you more time typing it in your calculator than actually doing it by hand, okay? So what we want to figure out is the determinant of this matrix, and then we need to multiply it by 1/2. So I'm going to kind of walk you through how to do this on your calculator, all right? And I've included some screenshots below. So the first thing you're going to want to do on your TI-84 graphing calculator is find your matrix menu. Again, your matrix menu is kind of down that left-hand side as far as things go. So once you open up your matrix menu, you want to arrow over to edit, okay? So we're going to arrow over to edit, and then you can pick any matrix. I'm going to pick matrix A, okay? After you hit enter 1, matrix A is going to come up. You're going to want to define your dimensions. Well, we had a 3 by 3 matrix, and then you'll want to enter it as follows. So we have 0, 0, 1, -2, 8, 1, and 4, 12, 1. At this stage, you've set up your matrix in your calculator. You should be good to run some calculations. So what you can do is just quit out of this once you have the matrix set up and go to your calculation screen where you type in 2 times 2. All right. At this stage, you want to go back into your matrix menu. You want to arrow over, instead of to edit, you want to arrow to math. And if you notice, these are all the calculations that will be run by your calculator. Oh my gosh. Look at the first thing, DET. I bet that means determinant. Okay. So you hit enter. What it's going to do, it's going to throw it up on your calculation screen. You then need to tell it what to find the determinant of. So you want to go back into your matrix menu and grab matrix A. So you can leave it at names, hit enter, or 1. So then it's going to throw in matrix A to your calculation screen. Determinant of A, hit enter, and you're going to get your answer is -56. All right. So when we go back up to this problem, we found the determinant was -56. Keep in mind with area problems, you guys, we're not going to have a negative. So this negative, I'm going to ignore. All right. And then we find out the area of this tiger cage is 28 square units. Okay, again, with area problems, we care about the absolute value of the determinants, not necessarily the determinant itself. So that's one application of how matrices can be useful. The second is in solving systems. All right. And this is Cramer's rule. It looks really complicated when you look at the box. Okay. But all you need to know is that's your system of equations. And then this is your coefficient matrix. Okay. It's the coefficients of X and Y. You have A, B, F, G. If you are trying to solve a variable, say X, you would take out your X coordinates, A and F. If you're trying to solve for Y, you're going to swap out B and G for your solutions, okay? And that's what we're going to show you right now. And I'm going to show you with the more complicated 3-variable system per your feedback requests, all right? So we want to do a little more complicated problems in the notes. So here we go. We're going to set up our coefficient matrix first. So we have 4, 5, 6, 3, negative 2, 7, 7, negative 6, and negative 8. All right. Very first thing you want to do is figure out the determinant of your coefficient matrix. Okay. As we figure out the determinant of this coefficient matrix, again, you can use your calculator to figure it out. Otherwise, you can copy the first 2 columns over and do it by hand. Either way, you should get 621. Okay, that's the first step and most important step to Cramer's rule. The next step is going to be that setup piece. So when we're looking for X, Y, and Z, that 621 is super important because what we do is we take a determinant of our modified matrix and we're always going to divide by the determinant of the original. Okay. So it looks super complicated, but if I'm finding X, I'm going to swap out my X column for those. So I'm going to plug in negative 14, 47, and 15. And then I'm going to leave the other 2 columns untouched. And again, if you want to use your calculator to figure out that determinant versus doing it by hand, you are more than welcome to. If I figure out the determinant of the top matrix, I find out it is 3,105. If I divide by the original determinant of 621, I get my X value is 5. Look at how convenient that works out. All right. According to Cramer's rule, if I'm looking for the Y's, I'm going to swap out my Y column. So I'm not going to use my Y's. I'm going to use the answers, which are negative 14, 47, and 15. That's the column I swap out. I leave the original X and Z coefficients in there. And again, just like before, I'm welcome to use my calculator to figure out the determinant of the top. I wind up with negative 1,242. I divide by 621, and I'm going to wind up with an answer of negative 2 for Y. The last matrix determinant, again, I need to solve for Z's. So I'm going to take out my Z coefficients, and I'm going to swap in the answers from the equations. When I figure out the determinant of that top matrix, again, using my calculator is probably the most easiest. I get 2,484. When I divide by 621, I get 4. So the answer to the system is 5, negative 2, and 4. So again, Cramer's rule does a really good job about making that process of solving 3-variable systems much more efficient. The nice thing about this is there's less room for error typically in terms of our algebra because we're just finding determinants. We're not doing linear combination, adding, subtracting, multiplying lines and adding them together. So this process tends to be a little more efficient for us and we're less likely to make mistakes. We also have the caveat that we get to use our calculator to do some of those calculations, which is nice. Okay. Keep in mind throughout your homework, quizzes work. This is what I should see on your assignment. So I should be able to see the determinant of your original. I should be able to see the setup for X, Y, and Z, and I should be able to find your answer, okay? What I don't want to see is the answer 5, -2, 4 with no work. If it says solving with Cramer's rule, I should be able to see you know how to find each variable using Cramer's rule, right? That's all for today. Again, hopefully this is a little more efficient process for you as far as things go. I know these problems do take a little time, especially to set up, but the fact that we get to use our calculator does speed up the process a little bit. Additionally, hopefully you notice that these problems don't take you 10 minutes anymore to do, especially if you make a mistake, all right? So that's that. If you have any questions, feel free to chime in. Otherwise, I look forward to hearing from you.